This is the recording for Chapter 7. This is Section 7-2. This is recording number 3. All right, where we left off is we were going to talk about example 7-6. Okay, so on this one, he's talking about the temperature. He took a random sample of temperatures. This was the high temperature, in other words, the highest temperature of the day, for 12 recent Thanksgiving days. And he doesn't give you the raw data. He just tells you these are the answers. This is your X bar, this is your standard deviation, and so forth. Now, on an exam problem or in an exercise, they might just give you the actual raw data, and it would be up to you to calculate the X bar and to calculate the standard deviations. So suppose you were asked to do that. Well, that's okay. You know how to do that. We did this in Chapter 3. Chapter 3, this is the end of Chapter 3. Here are the formulas at the end of chapter. Oh, doggone it. Here we go. So the formulas at the end of Chapter 3. Now, I may not have mentioned this explicitly because of this going online, but what I want to make sure I make clear to you is that I'm not asking you to memorize formulas. I don't believe that that's a good use of your time. What I will normally do in a regular class is I hand out the formula sheet. I may have to send that to you by way of email. We'll work that out later. But in any event, you know how to do this, okay? So if they gave you the data points, all of the temperatures for the last 12 Thanksgivings, that would be very straightforward for you to do the calculation for the X bar. Okay, it would be very straightforward for you to do the calculation for the standard deviation for the sample. Okay, so here it is. Gosh, where is it? Okay, here it is. Okay, that's the formula for the standard deviation for the sample, and then to get for the variance, this is the variance, this is S squared, and then obviously the standard deviation, you just take the square root. I feel like I'm not, there it is, here it is. Okay, so here it is, the square root of that formula. It's a little bit tedious. I would not necessarily ask you to do that in a live test because it's just a lot of busy work. And it's so easy to do it on a calculator, and it's so easy to do it on the internet calculators that it just doesn't seem like a good use of your time. However, I strongly urge you to do it a few times in real life just so you truly understand the formulas. If you don't do it, you're not going to really understand the formulas. Okay, so in any event, let's go ahead and talk about this one. So we've got the temperatures for the 12 recent Thanksgiving days. The X bar is 42. The variable is normally distributed. Okay, we want that to be true. And then the standard deviation of the sample temperatures is 8 degrees. So S is 8. Now, just real quick, N is 12, but he told you that it was normally distributed. If he had not told you that, then you'd have a problem because it has to be, for this test to work, it has to be either the original random variable has to be normally distributed or the sample size has to be 30 or above. But he solved that problem for you by saying the variable is normally distributed. Okay. Okay, so now sigma is unknown. We use S to replace it. So the author said earlier, and I challenged that language. The author said earlier that we were estimating the sigma. I don't think about it as estimating it. I just think that we're just using what we have. We're using the information that we have. So we're going to use the t distribution. The t distribution is going to give us this guy right here, the t value, the critical value, the t critical value, the t coefficient. Different authors use different terminology, but this guy t is going to be determined by the table. Okay, so let me do that for you, but this is the last time. You're going to have to learn how to do this yourself. Okay, so let me pause. Okay, so what he said he wanted 95% confidence level. I forgot to mention that. Okay, so 95% confidence level, N is 12. That's all we need to know to find the T. So let's do that. Okay, so this is table F, the so-called T distribution that's in the back of your book. Now in this particular example, n is 12. So since n is 12, our degree of freedom is 11. The author says he wants it to be a 95% confidence level. So remember, we're only looking at this top guy here, the confidence intervals, 95% confidence level for the 95%, and n is, as I just mentioned to you, n is 12. So you go here to 95%, that's the column you want. You come down and you go to the row that you want, which is the row is 11, because n is 12, therefore the degree of freedom is 11. So can you see that right here? You can see it in your book probably a lot easier. So it's 2.201. I claim is the appropriate choice for T. 2.201. Boom, there it is. Okay? All right. So hold on one second here. Got it? Sorry. Now, on this problem, he wrote down the formula again, which is a good thing. What's the bad thing is he's got a little tiny typo here. You see it right here? There's the typo. He has it S over n. It should be S over the square root of n, just like it is over here. That's unfortunate, but you know what? It's just almost impossible to write a math book without typos. Okay, so it's all just very, very straightforward now. So you plug in the numbers, calculate it out, and what do we have? What we have is that our best estimate for the mu is an interval, and it's an interval. We're 95% confident that the mu of the population is somewhere between 47.08 and 36.92. And we can say it that way, or we could also say that mu is equal to 42 plus or minus 5.08. Okay. Now, I've mentioned before, these are metaphors, right? So this isn't that exciting, but you could easily come up with examples that were of more interest to you. This is a big reason to look at the exercises at the back of the chapter. You'll find examples in the exercises that are a little more closely aligned with your major or your interests. I think this next example, example 7-7, I don't think has anything new. Oh, I see what it is. The reason he has this one is that he's got the actual test data here. Okay, so he has the actual test data, or the data points. Okay, these are number of houses that were started with a certain home fire or by candles. Okay, now I've mentioned, absolutely, I totally want you to do a few of these on your own by hand, okay? But the reality is you also need to know how to do it using calculators. So I'm going to Google that right now. I'm going to find an online calculator. I mean, obviously there's a bunch of them out there. Just find one that you like. Okay, after you use them a few times, you'll find ones that you like. I think Math Portal is one of the ones that I've used in the past. Okay. Oh, yeah, this is really a good one for other classes. I recommend this one. Math Portal. It has all these different types of calculators over here on the left-hand side. Let me see if I can move that over. Give me a second here. Okay. So there's all these different ones. This is the statistics calculator. Okay. Here's one, standard deviation calculator. This may not be the best one for our purposes, but it'll give you the idea here. Okay. They're all basically the same. You put in the data, you put in the information, and you separate them by either commas or colons or semicolons or a blank space. Most of them will use a comma. If you ever see the expression CSV, if they'll say put in the CSV data, CSV stands for comma separated variables. So you put that in there, you click what you want them to to calculate, and it's very, very handy. Here's let's hit right here. Most of them will do this. You hit examples, and it will give you an example here, okay? And it'll even give you an explanation of what everything is. This isn't the best one I've seen, but you get the idea. So in my view, my personal opinion, but you're welcome to do it your own way, I think these handheld calculators are not the best way to go. They're not used in industry based on my experience. I think that it takes you too much time to learn how to use their particular little nuances. For that particular calculator. There's so many calculators out there on the internet that are so simple to use. I just don't see the use of putting in the effort and the time to learn how to use a specific calculator type. Okay, so in any event, here we go. So how do we handle this? What we're trying to do, I'll let you read that. We're trying to find the 99% confidence level for the mean. Okay, so he doesn't give us the standard deviation of the population, so we have to use the t-score or the t-value. So here's the raw data. We find the mean and the standard deviation. We use the table F to find this t sub alpha over 2. We plug it in, and boom, there it is. Okay. All right. So here's a little explanation here. He says, hey, listen, how do you decide? I mean, it's so complicated. You got the formula in section 7-1. You got the formula in 7-2. Which one do I use? If you'll just keep this in mind, you won't have any problem on this, okay? If sigma is known, the z scores can be used, and it doesn't matter what the sample size is, okay? It doesn't matter, okay, if you know the sigma. So if you know sigma, you can use the z distribution, and it doesn't matter what the sample size is, so long as the variable is normally distributed or n is greater than or equal to 30. Okay, so that's the most restrictive condition. In other words, that's the hardest situation to be in. You have to know what sigma is, which is very difficult sometimes, okay? But if you do know what sigma is, if for some reason you have a reason to believe you know it, then you don't care about the sample size, and as long as the variable is normally distributed, or if you have a large enough sample size, n is greater than or equal to 30. If sigma is unknown and n is greater than or equal to 30, then we can use s instead of the sigma. We just have to do the best we can, okay? If sigma is unknown and n is less than 30, well, now we have to put a constraint on here. We have to say, hey, the variable has to be approximately normally distributed. So here's a summary. Do you know sigma? Yes or no? Yes, if you know it, we use the z value, we use sigma in the formula, and here's a little codicil, or excuse me, a little caveat here. Is sigma known? No. Then we have to use the t values, okay? And we use s in the formula. Okay, so look at these formulas at the end of the chapter, and I think a lot of this will be a lot easier for you to see the big picture. Okay, folks, so that's the end of this chapter. As always, or excuse me, of this section. As always, ladies and gentlemen, I strongly urge you, as much time as you can spare, look at all this other stuff. Look at the applying the concepts and so forth. It's well worth your time if you have it.